In this lesson, we will look at the derivatives of other trig functions. I'm not going to go through the proofs. You can look at those. They are in the guide. You can just look through them if you want, but I've just summarized the derivatives of other functions here that we're going to use to differentiate. So the derivative of tan x is secant squared x. The derivative of cosecant x is minus cosecant x cotangent x. The derivative of secant x is secant x tan x. And the derivative of cotangent x is minus cosecant squared x. And then I just added the two at the bottom that we did previously, sin x and cos x. So let's look at a couple of examples. So we want to differentiate y equals 3 tan 2x. So the 3 will remain the same. The tan, the derivative of tan x is secant squared x. So tan is going to become secant squared. And then the x is what is in the bracket, which is 2x. And then we'll take the derivative of the inside the bracket, 2x. So the derivative of that is 2. And then we'll just clean it up by multiplying the 3 and the 2 to get 6. Okay, secant squared x. So remember that we can write the square on the outside. So we are going to apply the chain rule. We will bring down the 2. The inside bracket remains the same. And then we take the derivative of the inside. The derivative of secant is secant x tan x. And then we can just multiply the two secants together. We'll get secant squared tan x. Likewise with cotangent, we can write the square on the outside, so it becomes the chain rule. Bring the 2 down. Cotangent remains the same. 2 minus 1 is 1. And then we'll take the derivative of the inside, which is the derivative of cotangent, which is cosecant minus cosecant squared x. And we don't really need to do much with that. Might put the negative at the front with the 2. And that's about it. Here we have a product rule. We have x squared times tan x. So we'll apply the product rule. So the derivative of x squared is 2x. Tan x remains the same. And then we'll take x squared. The derivative of tan x is secant squared x. Not really much to do here. I might factor out the common x, but really not much else to do beyond that. Okay, in 5 we have, let's write the power 3 on the outside. So we've got cotangent 1 minus 2x squared, and then that's all to the power 3. So we have the chain rule here. So probably going to need a bit of room here. So bring down the 3. Inside stays the same. 3 minus 1 is 2. Then we want to take the derivative of the inside. So cotangent is, derivative is cosecant squared. Inside bracket stays the same. Then we're going to multiply by the derivative of the inside, 1 minus 2x squared. So that's another chain rule. So bring down the 2. 1 minus 2x, and then take the derivative of the inside of that, which would be minus 2. Okay, so in this second group, I think I will clean that up a bit. I have a negative and a 2 and a negative 2. I can multiply together, which gives me 4. And then we have the cosecant 1 minus 2x squared. And then we have the 1 minus 2x. So all I did here was multiply this negative with this 2 with this minus 2. Okay, let's look at this example. So sine tan x. So this is not a product rule, it is a composition. So sine, the derivative of sine is cosine. And then tan x remains the same, and then we take the derivative of the inside function, which is tan x, so that would be secant squared x. So don't confuse that with a product rule. It's not sine x times tan x, it's a composition of functions. Likewise with this one, I'm going to change cube root of x to x to 1/3. So the derivative of secant is secant x tan x. So secant x and then tan x. And then we're going to take the derivative of the inside, so that would be 1/3 x. 1/3 minus 1 is minus 2/3. And then I'll just take care, I'll put roots back to, or rational expressions back to roots. So let's put that to the 3rd root of x. Let's put this back to the 3rd root of x. The 3 1/3, so the 3 can go on the bottom, and then x is negative, so let's put that on the bottom. And it's the 3rd root of x squared.